in the notes packet, I don't know what that noise was. That was weird. So up to now, and what was on your quiz yesterday was graphing sine and cosine functions. Okay, so now we're going to look at writing equations from trig graphs. So we're working in reverse now. So we still need to know about each of these attributes and where they come from in the equation, so that when we're writing the equation, we can plug them into the correct spot. So I'm going to try and use, I think I remember the colors we used. So the very last piece, the very last type of transformation we talked about was a vertical shift. And we said a vertical shift came from the number added or subtracted on the outside of the function. Okay, so it's not in the parentheses here. It's not part of what we're taking sine or cosine of, but it can be written at the front, at the beginning of the equation, or it can be written at the end outside the parentheses though. Okay, so it can show up there or there, but that D value, that's your vertical shift value. And we use that value to determine where the midline is. Remember on the quiz, it said to write the equation of the midline. Okay, the midline is y equals whatever that D value is. Okay, your other vertical transformation besides a vertical shift would be a vertical stretch or compression. Okay, and that came from the A value, the number multiplied on the outside of the function. Okay, so if we're multiplying our sine or cosine function by A, that's going to vertically stretch or compress the graph. It's going to affect the amplitude. So remember, the amplitude was half the height. It's the absolute value of that A in the equation. So notice there's a plus, I have a plus or minus in front of the A because it could be positive, it could be negative, okay? But the absolute value is what the amplitude is. So the amplitude itself is always positive, okay? If you want to put in parentheses that it's half the height, you can do that. Because if you can figure out the height of your graph, that's your maximum to your minimum, cut that in half, and that's your amplitude. Okay, halfway between the maximum and minimum, that's your midline. Amplitude is measured from the midline to the maximum or from the midline to the minimum. Okay. And then so those are both vertical transformations. The horizontal transformations come from inside the function, meaning it's part of what we're taking sine or cosine of. So your phase shift or horizontal shift, I think I colored that wrong. I think we used pink in the notes before, so I'm going to try and keep that consistent. But your phase shift or your horizontal shift comes from what? What part of the equation? It's what's added or subtracted inside the function. So I've abbreviated it here as HS for horizontal shift. But we talked about last week, your equation could be written without the B value factored out like it is here. So the B value, if it's written this way, you had sine, and then the B value is in the parentheses with the X, that number inside being added or subtracted, that's no longer the horizontal shift exactly. We use it to find the horizontal shift, but it's not the horizontal shift itself because that B has been multiplied into it. So you have to take that C value and divide out the B if it's written in this format. And then we also have to remember that it's the opposite sign of what you see there. So it's negative C divided by B. That's your horizontal shift or phase shift. Now these, where the b is already factored out, it's already divided out, what you're left with is the horizontal shift value. So that's why I've written this as x minus the horizontal shift. And I've written it as minus because that takes care of the fact that it's the opposite sign. Okay, and then the last thing was the period. Remember, the period comes from the b value, whether it's inside or outside the parenthesis. It's still part of what we're taking sine or cosine of. So it's inside the function, but if b is factored out, or if it's not factored out, that doesn't change the b value itself. So the b value is used to determine the period. The b value is not the period itself. So it's 2 pi divided by b. Or if we're going to work in degrees, which we will sometimes, your practice today is going to be about half in degrees, half in radians. What is 2 pi if I convert to degrees? 360. So it could be 360 divided by b if you were in degrees. Now, going from the equation to the graph, we can see b and we use it, plug it in here, and find the period. But going backward from the graph to the equation, we actually are going to be working in reverse of that. We're going to know the period. Looking at the graph, we can figure out the period, and we need to use the period to figure out b so we can write our equation. So if I wanted to solve this for b, instead of having it solved for the period, they would end up just switching spots. B would be 2 pi divided by the period, or 360 if we're in degrees, divided by the period. And that would give me the b. So it depends which direction you're working, which format of that you will need. Everybody good on that little recap? All right. The other thing we need to make sure we understand, besides what all of the pieces of the equation mean in terms of transformations, is what the cycle of the graph looks like. There are 4 different cycles that we can write the graph of a sinusoid, the equation of the graph of a sinusoid in terms of. So that's up here. What this plus or minus is really referring to. So that plus or minus in front of the A, that's telling you if it's a positive or a negative trig function. So if this is a negative, that means we're looking for a negative sine cycle. Okay, and this could be cosine instead of sine. It's not always sine. Okay, if it's positive though, you're not going to see a plus sign written unless it's in this format with the D first, because then you would have to show the plus. Okay, but if there's no plus or minus written here, that would be an understood positive. Okay, so what the cycles look like, you have positive sine, starts on the midline, high, midline, low, back to midline. Okay, so that's the sine, positive sine cycle. Negative sine is the reflection of that over the x. So we start on the midline, but we go down to the low first, and then up to the high and back to the end at the midline. Okay, so it's just a reflection of positive sine. Positive cosine goes high point to high point. So it goes high, middle, low, high. If we put a negative in front of that, it reflects it. So it goes low point to low point. Everybody good with the shape of the cycles? Because that's going to determine, like in a sinusoid, when we have a graph of a sinusoid, it could show lots of cycles. And we have to narrow it down to one of these. So you have to know where you're supposed to be looking. Okay, or it could have just a couple and you get a choice. You can pick. So in this first one, It says that the y-axis is scaled by ones and that the x-axis is scaled by 45 degrees. So this one's going to be in degrees, not radians. And we're going to practice writing the equation in two different ways. So we're going to write it in terms of positive sign and in terms of negative sign. So before I jump into anything, I'm going to write the equation up here. So we're going to have positive or negative A, and then this one is sine. I'm going to write it with the B factored out because it's easier to see your horizontal shift. Okay, so this is the format. Okay, so I'm going to start by identifying my maximum and minimum. And notice these are the exact same graph. I'm going to write two different equations that graph exactly the same by just simply changing the cycle that I'm looking at. Okay, so the maximum is at what y value? What is that maximum? The y-axis is scaled by ones. So that's at 5. Okay, where's the minimum? So what is the height of this graph from minimum to maximum? So we have a height of 6. That's not any of the key components yet, is it? But it's going to help me find one of them. What's it going to help me find? Because the amplitude is half the height. So if the height is 6, the amplitude is 3. So I'm going to come down 3 from the maximum, or you could come up 3 from the minimum. That's your amplitude. Where does that put you? When you come from down 3 from the maximum or up 3 from the minimum, what does this represent? So I'm going to sketch my midline there. So that is my vertical shift. And this is at what value? Where is that midline? 2. So the vertical shift is positive 2. It's up 2. It's 2 above the x-axis. So I've got my vertical shift. I've got my amplitude. Okay, so now I need my period and my horizontal shift. Well, I am looking, no, notice I did both. I did amplitude and vertical shift. I can do that without knowing what trig function I'm looking for, sine, cosine, positive or negative. Amplitude and vertical shift aren't going to change. It's going to be the same. Those two will be the same no matter what. Same for the period. But you can measure the period different places. You could measure the period high point to high point, low point to low point. But in this particular graph, I can't do either of those things because there's not a second high point shown. There's not a second low point shown, right? I mean, I could extend the graph to create one, but it's not necessary because those aren't the only places to measure your period. We could measure the sine cycle. I'm going to go ahead and highlight a positive sine cycle. We said starts at the midline, going up. And then it ends at the midline again there, where it would continue to go up. And that would be another cycle. So there is a positive sine cycle. So I can use that to measure my period. So that starting point is where? What did they say the x-axis is scaled by? Okay, so this starting point is where? At 45 degrees, because it's 1 square over from the y-axis. Okay, so my horizontal shift is to the right 45 degrees. Now, if each square is 45 degrees, I'd make this 90, 135, 180, 225, 270, 315, 360. And where would this last piece be? It was another 45. 405. Okay, so when I'm measuring my period, it's going from 45 to 405. That's the distance, like the span. So the distance between them, I take the higher number and subtract the lower number. 405 minus 45 is what? So the period is 360. So that means my B value is 360 divided by the period, which is also 360. So what's 360 divided by 360? So the B value is just going to be 1 in my equation. So I think I have everything I need to write my equation now. I have my amplitude. I'm going to go here. I have that B value. It's going to go here. I have my horizontal shift. And I have my vertical shift. And I'm writing this one as a positive sine cycle. So that's going to be, I'm going to pick, am I using a plus or minus? And then here's sine or cosine. Okay, so when I write this equation, it's positive, so I don't have to write the plus. It'll be an understood positive. 3 sine. It's an understood 1. I do not have to write an understood 1. My horizontal shift is 45 degrees. And the vertical shift is 2. It's positive 2, so it's plus 2 here. I wrote this as a sine cycle. The B is an understood 1 here. The vertical shift. Here's my amplitude, my A. And there's my horizontal shift. That make sense? You'll see how we went backward from the graph? Okay. Now, right by it is the exact same graph, but this time they want us to write it as negative sign instead of positive sign. So the only thing that will change when you change the trig function, or whether it's positive or negative, would be this in yellow. So the positive or negative and the sine or cosine can change. And the only thing that changes with that is the horizontal shift. The size of the graph does not change. The only thing that changes is your starting point that you're using. The amplitude won't change. The period won't change. The vertical shift, where the midline is, won't change. The only thing that changes when you change this function is the horizontal shift. So in our graph, we can see this still has the same. I really don't know why this is not. I was having this issue last class. When I try to write on the graph over here, it moves everything off to the side. It's really weird. Let me see if I it is in the back. Front. And try writing on it. Let's see if that makes a difference. Nope. It keeps moving all of my little things way over here. That's strange. On yours, on paper, draw the midline in the exact same spot here. Okay, so the midline did not change, so the vertical shift stays the same. Okay, where the maximum and the minimum were did not change. So the amplitude's going to remain the same, right? Y'all agree? Okay. The width of the graph, it has not changed. It's not stretched or compressed. It's the exact same graph we're just working with. So the B value is not going to change. The only difference is when we look for a negative sine cycle, sine started midline, went up, down to low, back to midline. This is the shape of the positive sine cycle. Negative sine starts at the midline, but goes down first and then to the high and back to the midline. So the only difference is we're looking for a different starting point. So instead of starting on the midline here, going up first, we're going to start on the midline here and go down first. So I only see a piece of it. That's only half of it. I don't see it would continue in this fashion over here, right? When I pick up my pen, though, that's going to move since I don't know what's going on with this. But that's what I want you to kind of outline or highlight it or box in is this right here, because that's a negative sine cycle. So the only difference is we have a different starting point. So my starting point is here now instead of at 45 degrees. So what is the degree measure here? If each box is 45 degrees, you can figure out that this starting point right here is at, say it again, it's at 225. So I want you to label this spot right here as 225. When I lift my pen, this is going to move. Yep. So weird. I don't know why it's doing that. It's only for that one that it's doing it for, too. All right. So when I write this equation, what changes is this is now negative. So I'm going to put a negative in front. The amplitude does not change. It's negative sine. The understood 1 for B does not change. The horizontal shift does. Instead of 45, we're starting this one at 225. But the vertical shift where the midline is does not change. So what changed was that I made this negative sign instead of positive sign, and I changed the horizontal shift. Those are the only 3 things that are different from this one over here. Do you feel okay about that? So only the horizontal shift changes if you change which cycle you're looking at. Good? All right, let's try one more. Same thing. This time it's in radians. It says the x-axis is scaled by pi/4. The y-axis is still scaled by 1. So let's go ahead and figure out the maximum and minimum and draw our midline. So how high is the maximum for this graph? Okay, how low is the minimum? So the height of the graph is 4, which means the amplitude is 2, which puts the midline where? At halfway between, so at -2. So I'm going to go ahead and draw my midline, label that as my vertical shift. So the vertical shift is -2. You said the amplitude is 2. Doesn't matter if you measured from the low or the high to that midline. And that's the same on this graph over here, right? No change. Same amplitude, same midline, vertical shift. Okay. For the first one, we are looking for a cosine cycle. So we need to know the shape of cosine is high point to high point. On the second one, we're looking for negative cosine. So it's going to be low point to low point. So I'm just going to highlight the cycle. So cosine, high point, high point. Negative cosine, low point to low point. It's the same graph though. I'm just focusing in on a different piece of the graph. So the period is not going to change whether you measure it here or here. It's going to be the same width. So each of these squares was pi fourths. So this is 1, 2, 3, 4 squares. So that's 4 pi fourths, which is just what? So the period is pi. Now I use that to find b. So b in radians, it would be 2 pi instead of 360, divided by the period, which we just said was pi. So what's 2 pi divided by pi? Just 2. The pi's reduce. So b is 2. It's the same width here. Wasn't this 4 squares wide also? Just measured in a different spot, but the size of it does not change. Okay, so everything's the same still. So the only thing that's going to be different is the starting point. So this is the starting point of a positive cosine cycle. And where is this located? At what x value here? At pi fourths. So this one has a horizontal shift of pi fourths. This starting point is where? What's the x value here? 3 pi, it's 3 squares over, so it's 3 pi fourths. So that's the horizontal shift for this one. So that's the only thing that's different is the horizontal shift. So when I write my equation, this one is positive cosine, so I don't need a plus, but my amplitude is 2. This is cosine this time. We said the b is 2. The horizontal shift is pi fourths. And the vertical shift is down 2, so that's minus 2. So I did positive cosine, amplitude of 2, vertical shift down 2. The b came out to 2. Lots of 2's in this one. And the horizontal shift was pi fourths. So what would I write to put this in terms of negative cosine? What would this equation over here be? What's going to be different about it than this one we just wrote? It's going to be negative. Is the amplitude going to change? Okay, it's still cosine. It's just negative cosine this time. Is the b changed? No. Is the horizontal shift changed? Yes, it's 3 pi fourths now. Is the vertical shift changed? No, still minus 2. So literally the only difference between these two is that it's negative cosine this time instead of positive cosine. And the horizontal shift is 3 pi fourths instead of 1 pi fourth. Everything else stayed the same. So the reason I did some that are exactly the same side by side is to show you there's more than one correct answer for a lot of these problems. So on your assignment, that packet I gave you with the worksheets, and I gave them all stapled together last week, and I was like, last week, these are optional practice. Worksheet 1 went with notes part 1, worksheet 2 went with notes part 2, right? And then the third worksheet was a compilation of those two. It was doing all of the transformations together. But we had the Delta Math assignment. I said, if you want to practice on paper, you can. The very last page of that packet, though, I think it's worksheet 4. Oh, hang on. That one's the key. I don't want that one. That goes with these notes, the very last page. Nope, that's notes. Where is this worksheet? Oh, here it is. Okay. So this one it says Unit 3 Graphing Worksheet 4. Okay, so this is the very last page of that packet. If you want to rip it off, because we're actually going to, this one is not optional. Those first 3 were optional last week, but now that we've covered these notes, we're actually going to do this practice on paper instead of on Delta Math. So in this first section, the first 8, you are not graphing these. You are simply giving those 4 components: the amplitude, period, phase shift, vertical shift. Notice 1 through 4, these are in degrees. 5 through 8 are in radians because you see pi somewhere in one of the values, right? So the first 4 are in degrees, the second 4 are in radians. You need to make a note of that. So that's just giving those 4 important pieces. Then you're given graphs, and we want to use the amplitude, period, phase shift, and vertical shift to write the equation for each sinusoid. And it says use the trig function specified. Okay, so for instance, number 9, I tell you, write it as negative sign. For 10, I tell you, write a positive sign equation. So this way we won't have as many variations. Most of us will have the same answers because we're working with the same trig cycle. Does that make sense? Okay, you'll notice this front side, all of these graphs are in degrees. If you flip over to the back, we're still in degrees until number 18. 18 is the last one in degrees. So if you want to like draw a line here to separate, so you know the up to 18 is in degrees, the rest of these 19 through 24 are in radians. Okay, even though you don't see pi on the x-axis, these are in radians. Okay, so do these in radians, these 19 on. Now, this is a lot of graphs. I don't need you to do every single one of these. So I'm going to tell you how I want you to split it up. I want all of 1 through 8. You're going to do all of 1 through 8. But when you get to the graphs, I want you to do half of them at least. But I don't want you to split it to where you're just doing all degrees or all radians. So when you look at them, there's 2 columns. Do at least 1 of 9 and 10. Do at least 1 of 11 and 12. Do at least 1 of 13 or 14. Does that make sense? I don't care if it's all odds or all evens, or if you want to switch it up back and forth and make like a zigzag, that's fine. So you're going to end up doing at least half of these graphs, but I don't want you to split it where you're doing like all radians or all degrees. So as you go in each row, do 1 from each row. You can pick which column it's out of. Does that make sense to everybody? You'll notice when you get past 20, I stop telling you which trig function to do, The last four say your choice. So you can pick if you want to use sine, cosine, negative sine, or negative cosine. Okay, you pick one of those four to write your equation in terms of. Good? Okay. So y'all have the rest of class to work on this. Again, you're doing half of the graphs, but all of the first section. So do all 8 of these, and then you're going to do half of the graphs. Okay? All right. This will be due on Thursday. I am going to be out Thursday. That's our first golf tournament of the spring semester. I'm going to post the golf schedule on our bulletin board up there so you can see ahead of time the dates of the tournaments so you'll know when I'm going to be out. But just remember, same expectations as last semester when I'm out for tournaments. If it's a work day, which this Thursday is going to end up being a work day, it's a day for you just to work on the practice. We'll have taken the notes. You're working on practice. Okay. You're expected to do your work. Okay. If it's a day where it is, I would be teaching that day. If I were here, I'd be teaching a lesson. There's going to be the video lesson posted. So you'll either already have the hard copy of the notes or it'll get passed out for the outline. And then you'll go on to It's Learning and you'll go and watch the video that I posted and take your notes. Like listen and watch the lesson and take your notes, just like you would if I was in class. It's just the screen capture of what's on the screen right now, and you hear my voice and you see my writing and all of that. Okay? All right, so this is going to be due Thursday. I won't be here to remind you though. So you have to know to turn this in by the end of class or the end of the day, come by and drop it, put it in the top tray on Thursday. Okay, so if you need class time to work on it Thursday, you can, but then the assignment I'm leaving you for Thursday, the new practice, you'll have to do at home on your own then. If you're going to work on this in class Thursday, if you don't finish this for homework tonight or tomorrow night. Any questions? Yeah. Your packet didn't? Okay, I'll get you one. All right. If for some reason your packet that you got last week didn't have the last page, if it got torn off or something, it is also posted in It's Learning. So you can go to, this is the Unit 3 Part 2 folder. If you go to resources to that folder, note outlines, or actually it wouldn't be note outlines, it'd be assignments. All of those worksheets from that packet are posted there as PDFs, and you can just print that last single page. You don't have to print the whole packet. But I think I have a couple extra hard copies as well. All right. You'll have the rest of class to work on this.